Bonjour. Je suis désolé. Je suis un mauvais Canadian. I'm a bad Canadian. I don't know any French, so I'm sorry for that for anyone that's French speaking here. But goal for today, my name's Cody. I'm going to take you through a snapshot of where inspection robots are today and try and give you a side-by-side comparison. And I've got real-world footage here to share with you as well, so I'll jump to that, and then hopefully if you have any questions, we can talk through some of the applications even more. But to start, Deep Trekker. We are a underwater robot manufacturer. We started about 16 years ago. Our first sale was actually a Norwegian fish farm supplier. They found us on a absolutely awful looking website, and they bought the first 10 units. That paid for the parts to get started. Early in our existence, we were mostly focused on sales to yachties who wanted to go look at shipwrecks and wanted to look for treasure. But very quickly, we learned that there was a lot of other applications that were really interesting for our robots. So that included nuclear power plants. Our first sale was for a reactor pool inspection to St. Lucie's power plant in Florida. That was in 2012. From there, fast forward to today, and we've got hundreds of vehicles just in the nuclear sector alone. Most of our experience is in North America. We've sold to various plants there, ranging from Constellation, Dominion, Duke Energy, Evergy, Bruce Power, OPG. And now we're starting to get traction here in Europe through our partners. So in the top left is our local French reseller, Escadron. And then we also have just made our first delivery to EDF and to Framatome as well. Most of the applications that you'll see for Deep Trekker are inspection related. There's some small tasks that you can do, things like manipulation of objects, some cleaning tasks, but the number one thing is inspections. And the value of those inspections is, one, I'm able to operate a robot in and do the inspection rather than putting people in harm's way. You're taking a handheld controller, it's tethered to the vehicle, and then you're able to tell it where to go, drive where the sensors want to go, where the cameras need to go, and then you're getting your live stream back to you on your handheld controller. What this does is this really enhances the whole safety of the operation. You're avoiding people needing to take unnecessary dose. You're able to keep people out of dangerous scenarios, underwater, confined space. You're able to eliminate all of that. The other benefit is that it's actually a big cost savings too. Our robots can be as little as $10,000, and in comparison, the cost to do a full dive operation during an outage, one, just the diving costs alone can be in the $100,000 or more range, and then you can also see a greater cost if something goes wrong and you're in an outage. But the main application I want to start with is the core application. Most people will use a ROV to be able to do a visual inspection. What you see here is an image from a plant in Illinois and the entry into a traveling screen inspection. So this is actually on the cold side of the plant, but it's a great shot to show you how portable the setup is. These are guide flexure tubes within a reactor. So this is one example shot here. It gives you an idea of the water clarity. It's very nice, so it's easy for cameras to be able to work. The value here also is that the ROV is able to swim close to these structures and get detailed analysis of the condition. And you can also start to build models to do measurements. We also have zoom camera capability, so if you want to zoom into one of these flexures, you're able to get a better look. This is a pressurized water reactor tank. You'll see on the right there is some fuel rods. So those go up and down. As they go down, they're delivering more fuel, and as they go up, then they're delivering less. Short answer is the vehicle is able to fit into this area safely, even when there is radiation. They're able to go and get a look at these structures and be able to provide data that typically is quite difficult to reach. Here's a cap on a reactor. You're able to lift the cap and then get a look at the rods. underneath, so the ROV could actually fly below as that's lifted up. This here is an example of a condenser tank in Florida. So this robot here, what was unique about this application is that this was an incredibly difficult structure to be able to get eyes in. You can see a little bit from the right picture there that there's a bunch of structures, rods, various things to get tangled on. It certainly took a very patient pilot. I wouldn't recommend a new pilot try this type of inspection, but the good news was they were able to get a view on a structure that they had never looked at previously because it was too dangerous to be able to get eyes on. So this one here I really like because the customer actually designed their own way of putting in a plug. So they had their own sealant that they applied to a leak. This leak had been their longest standing issue at the plant. It had prevented them from doing a valve repair, but they were able to create their own solution using our grabber to apply a sealant, and then they were able to isolate the valve, perform the repair, all while avoiding needing to deploy divers. And then this is here from a buoy, so you're able to go and get a close inspection on structures as well, even in more murky and more turbid environments. And also as well, so the grabber was used to apply a carabiner with a line to the structure. So you're not going to necessarily be turning, making repairs or doing any sort of welding with an ROV of our size, but what you can do is get creative and be able to utilize various tools to perform small tasks. Just another example of a place you could use the ROVs is not necessarily all high radiation environments. It can just be for cooling water storage tanks. Those are structures that, again, are dangerous to be able to put people into, put divers into. It's a much more cost-effective way to use a robot to go and do it instead. But what I want to cover now is some of the up-and-coming technology that is coming for getting various visuals on structures. One is a laser scanner. This is the type of technology that will give you the absolute highest precision. However, it is also by far the most difficult and time-consuming option to use. So what I caution is anyone that looks at unmanned technology of any kind, if you push for a certain level of precision, you might be adding some other problems to your operation that you're not realizing. So this is a comparison here between a multi-beam echo sounder, which is a sonar technology, and then a dynamic laser scanner. Laser scanning is going to give you more detail to a sub-millimetric level if you do it properly, but a multi-beam sonar can still give you a decent point cloud. So it depends on what kind of understanding I want to have. Do I need sub-millimetric understanding in order to shape a specific part, for example? Then perhaps laser scanning is a good option. Lasers are great for short distances. If I want to just have one small area and be able to really understand that size, an example here is a pit. This is a pit in a wall. Then this is a great way to be able to measure that pit. I can get in close, and the way the laser scanner works is it's time of flight sensing. It's just saying how long does this laser take to get to that structure. You sit there and scan for a couple of minutes, then you can get data like this. But if I tried to do a full tank with that sort of technology, you might be there the whole year. A direction that might be a nice middle ground in the future is technology like stereo cameras. This is still early in terms of proving it out as a full option for doing true measurements, but what we've seen from the results so far is that it's quite promising. You're able to generate 3D models live. These 3D models are not going to be sub-millimetric in accuracy, but what they will be is within a centimeter if you do it properly. And it's great from a visual standpoint because it's lifelike. So it can be more intuitive to go and find various structural issues. Maybe hands up, does anyone already here, is anyone already aware of photogrammetry? Who knows about photogrammetry? Not a single person. All right, so Photogrammetry is the process that's used here to stitch this model together. What it is it's taking a photo and marrying and edge detecting what does this photo kind of look like that's next to it. And then you do that with thousands of photos, and you're able to then position them all in relation to each other, and then that creates the model. What's very important is to have a very clear picture. The problem with underwater is that the picture is often not so clear. So you can get great results, and then I can go to another area of the plant. Maybe it's a pond or an intake structure, and I'll have no visibility, and photogrammetry won't be an option. So it's important to understand environment before choosing which technology to use. Photogrammetry is really popular with aerial drones. It's really well proven in that area. In underwater, it's still something that we're working toward, but we're like with structures like this, you're able to see that the results are coming along. Got one more here. This is an example within a storage tank. Why I pulled this one, it doesn't look as pretty, but it was really impressive because it was only about 100 photos, and it took only a couple minutes to create. So it was in terms of an operational speed, it was a good example. My personal favorite when operating an ROV is an imaging sonar. So imaging sonar is by far the easiest for a newer pilot to be able to use, and it's the most reliable even when there's murky water. And oftentimes there's murky water, except for in a nice reactor pool. This is an example from a dam wall. This dam wall here took it was about a 10-minute operation to be able to go across the dam. The dam is about 20 meters wide. And we're able to get a very good, clear understanding of sediment levels through our scans, and we're able to tell any major defects. I would not be able to pick out small pits and cracks in the wall. I'm not going to be able to make very, very fine decisions with the data, but I can certainly find major issues with this. What I also might be able to do is narrow down which areas do I want to do laser scanning with, which ones do I want to make a photogrammetric model of. Because if I was to try and do a photogrammetric model of this dam, it would take me a full day versus that 10-minute operation. This is a sneak peek at that same dam. We have some new technology that we're starting to work toward. We're starting to work with 3D sonars. Traditionally in the past, long story short on 3D sonars is that they're very, very expensive, very large. We're starting to see miniaturization of these sensors. And then what you see here is this rainbow color. That's what you would be seeing live. But why it's valuable is what we're doing with our software is I can actually tell where I'm moving. But I'm guessing by the photogrammetry question that do we have any ROV pilots in here? Has anyone driven any sort of drone in their life? All right. So a main thing about knowing when driving any sort of robot is that the hardest question to answer is where am I and where do I need to go next? It's very easy to get lost when you're driving any sort of robot, but especially if you don't have good visuals. So you can imagine if I'm driving something and I have completely muddy water in front of me, I don't know how have I covered the whole dam and what part of the wall am I looking at? The sonar is able to help and develop that model as I'm going, which then tells me where do I need to go next and what do I need to scan, what have I scanned already. One other capability that I'll mention, we can do a wide variety of sensors, but on our robots you can also add things like ultrasonic thickness testing. So if I wanted to be able to look for the thickness of steel, you can put a probe on for that. Here's the example. It attaches where our grabber does, and then you can drive and place it on a steel structure and you get your reading there on the screen. You can see here an example, and the reading pops up there. This is an example of a new delivery that we'll be making early next year. We are working with our partners at Dominion Energy in Virginia, and we'll be delivering them a pipe crawling robot that has a 5-function arm on it. So I can use that to go into ducts and into pipes and collect maybe a lost tool, lost screw. Great tool to be able to be part of your FME program. Here's a quick quote from our customer in Illinois out of the Clinton Constellation plant. Reason I wanted to bring this one quote up is that actually they were able to prove that they saved millions of dollars through the use of a deep Trekker ROV. And that was all because we were able to shorten the time of an outage by making an inspection, an emergency inspection happen that wouldn't have otherwise been possible with ours. So one great example of ROVs, but hopefully some of the other photos help demonstrate the capabilities as well. So as a quick recap, again, why would we turn to unmanned systems to be able to do these inspections? The number one reason is that it makes operations a lot easier than before. You don't have to have those questions about what's the condition of a structure and is it going to cost me hundreds of thousands or millions to be able to do the inspection. They're also very easy to maintain. They go into high radiation areas, and the vast majority of our systems can be decontaminated with simply soap and water. It's also the convenience factor. So a lot of plants want to have a tool on hand in case of something happening. I want to be able to get eyes on a situation. And if I had to rely on going to a quote request, or if I had to rely on hiring an emergency diver, you might be waiting hours or days before being able to get eyes on a potentially risky situation. And then to improve the safety factor, again, talked about removing men from the equation, and then reducing costs, so being able to make operations more efficient. So on that note, I wanted to open the floor if there's any questions at all about unmanned systems. If not, and you feel free to come to D23. I don't know if we got that on there. D23, we've got some of our robots there if you wanted to take a peek at it, and some more footage, and I'm happy to share. So thank you. Merci beaucoup.